Whoa, so the previous video was like 20 plus minutes. This one will be about the same, but yeah, please do hold on, and because it is sort of important, right? So we can do some cool stuff with the script. And so yeah, let's open it and have a look. So this is my drone position, and then I've given a set point as is mentioned in your document of 2, 2, 20. Some basic declaration over here. And then what I have here is my PID gains, basically the constants, the proportional constant, the integral constant, and the derivative constant. And these are all lists. The first element represents the constant for roll, the second one for pitch, and the third one for throttle. So it might not always be the case that the constants for roll and pitch which you arrive at are the same. So it again depends on various physical constraints of the drone which you'll be using, like of any drone which you use basically. So now what happens here is all of the stuff is filled out over here, the comments, you can just read that at length. So for the benefit of keeping this video short, let's just move on. Then what will happen here is we are just declaring a publisher, raspi.publisher, which publishes to the topic drone command of the type of messages of the type edrone_messages. We have subscribers over here. So the first subscriber is of Vicon poses. You must already have dealt with this in your task 0. Now the second subscriber is of a package called PID tune. The message type is PID tune. And over here, this is the callback function, which is the function that will be executed for here. So you have to write like basically the PID tune package. It publishes on multiple topics. Please use the command ras topic list to check out what topics it's publishing on. We'll look into that in a very short while. The topics on which PID tune publishes. So this particular topic is for the altitude. Okay, there will be topics for the roll and pitch as well. So all of them will have independent callback functions. So what happens in the callback function is you just set your gains to this alt is the message received basically. It consists of 3 things: KP, KI, and KD, the constants. Some numerals basically. You scale them essentially for more fine tuning. So if let's say KP ranges from 1 to 1000, just an example, we'll look into the real one in a while. 1 to 1000. If I just scale it by this, my resolution is my range is decreased, but my resolution is increased. So this fraction is up to you. You can just set it as however you want. So basically the fraction for Ki will be pretty low because typically Ki values are very low. And then it will then follow the steps over here to calculate, like to complete the PID function. Okay. Now the PID function will function at a certain sample time. So this thing over here, raspi rate, will specify the desired sample time basically. Another point to note here is that the PID function, after the computation, what happens is you publish something. So what is this something? So this is nothing other than you publish on the topic /drone command with the message type edrone_messages. So you do all of your computation, you calculate the errors, and then with respect to that you assign appropriate roll, pitch, and throttle values, RC roll, RC pitch, RC throttle, put them in the format of the edrone_messages, and just publish it at a certain rate. Okay, so that's it for the script. Then let's see this working and in action. So I already have a backup script which I filled out, and just rudimentary values, whatever worked first. So I'll just run that script. I put in the gains are not fine-tuned, but let's see how they behave. So just you can use the rosrun command, survey and rescue. position hold gazebo completed.py. So when I press enter, you will notice the drone has taken off, and remember our set point is 2,2,20 as mentioned in the document. So as you can see, this is not the fastest response. You can have a much better script than this. So yeah, it is almost there in throttle, it's reaching there in roll and pitch, and then it approximately settles at the set point over here. It is hovering at the set point. You need to be much closer than this. The threshold will be specified in your document. So how do we achieve a very fine tuning? Well, one way of doing that is graphically using the package PID tune, and we'll look into that for a moment, but before that, let's look at a very important package called plot juggler. So now you have the Vicon coordinates, so you know your set point. So there's always going to be an error, which is your set point minus the coordinates, or however you calculate it. So how do you visualize the error, and how do you visualize the error changing in real time? So for that, we typically use a package called plot juggler. It's a ROS package. It is available for things other than ROS as well. You can just Google plot juggler and you'll find it. So you'll need to install this first. So in order to do that, let's do that in a minute, but let's first browse through the web page of plot juggler. You can do lots and lots of things with it, or else we'll go to the ROS wiki, not the GitHub page. So yeah, you can just map out graphically how your I should move this to another workspace, shouldn't I? Firefox, move to workspace number 3. So now if I do Control Alt down, I have Firefox and only Firefox. So as you can see, you can visualize lots of data, gather information from this package over here. So how do you install it? It's a very simple command. You can either clone the package and do all of that, or you can just do sudo apt install ROS-kinetic- plot juggler. I'll enter my password, and it's getting the plot juggler now. So over here, I'll just briefly walk you through it. You can see all of the topics that are being published, and then you can subscribe to, you can just list any one of those and then drag and drop them to the windows over here. And then as and when the topics changes, the data on the topics changes, that will be reflected in real time in this GUI. So as you can see now, after a while, our drone has stabilized quite well. You can achieve much faster responses than this. So we'll look into that in just a moment, of how to efficiently, with just some trial and error, achieve a very nice response. So let's look into plot juggler after it has been installed. And remember, as you saw in that splash screen over there, do run the apt update command before doing this. So the command is rosrun plot juggler, and with a capital T, plot juggler. Okay, nice splash screen here. They recently updated this, lots of memes included. So now you go to the taskbar on the upper left, go to the streaming section, and then click on Start ROS Topic Streamer. Over here, all of the topics which are currently active, published and subscribed, mainly published, all of the topics which are being published will be displayed in this list along with their data type. So what we need over here is the alt error, the pitch error, and the roll errors. So these errors I'm publishing myself from the PID script, like current minus set point, however you calculate that, and in the format of standard messages /float64. Along with that, I'm also publishing the drone command just to get some insight into how the error reflects with the RC roll pitch and RC throttle elements of our eDrone_messages. So when I click OK, all of the topics will show up in the left pane. I can then split this right pane into multiple sections. So what I'll do now is I'll put RC roll, pitch, and throttle in one pane. I could literally also split it into multiple ones. I just put all of these together in one pane because the range of their values is sort of similar, right? All three of them could only go from 1000 to 2000. But if I had plotted them along with the errors, as you can see here, the alt error is almost close to 0 now. And so that will be a huge difference in the ranges, so it won't look nice in the graph. So it is always good to plot values which are similar together, basically. So I plotted the alt, roll and pitch here as well. So now let's just let's switch plot juggler to another workspace. I have no need for the browser here, so if I just go to the browser and I just delete this, I can literally take plot juggler from here as well. So but yeah, before I'll just explicitly move this. I'll move this to workspace 4. Okay, let's do workspace 3 and maximize it there. Yeah, so now what I'll do is I'll just reset the drone model and let's see how it behaves. So this is our RC roll, throttle and pitch commands, and here you can see the roll error and pitch error. They are similar in colors and they are tracking each other quite nice, like quite closely basically. So that's why they are appearing as one over here. So if I just decrease the streaming time, yeah, just to 5 seconds. So 5 seconds is the total buffer which it will store, and then it will disappear to the left. You can increase or decrease the buffer here basically. So as you can see, the response is pretty slow. So how do you effectively tune your response? So do you just stop the Python script, change your gains, run it again or something like that? Well, you could do that and it would not take many iterations, but to make your job even simpler, there is another tool at our disposal. It is called PID tune. So I'll just you must have already cloned the PID tune package. So let's just raw cd into it and look at its structure. So what the PID tune package essentially has is the launch files from which you can control how many GUIs will appear. We'll look into that shortly. The standard lists, the standard things like package.xml and CMake lists. And then in the script section, what you have is the scripts for tuning different things. Okay, so one is the actual GUI, then we have the PID tune drone and the PID tune differential. So the differential is for differential drive robot, so if you're just in case doing like line following and everything. So if a file is executable as shown in green here, you can use the run command. Otherwise you'll have to make it executable before doing this command. But you can use the Python command regardless of whether it is executable or not. So as you can see here, this pidlib.pyc file is not showing up in green, so it's not executable basically. So run PID tune and then PID tune drone.py. So when I do this, all of these show up for the throttle, roll, pitch and yaw. So we'll look into them in a moment. So as you can see now, if I reset, I have written subscribers for PID tune as I showed you already in the boilerplate code. So since these GUIs have popped up, we'll keep them in the same pane as the plot juggler thing. So before that, since these have popped up, the values they are publishing, the values of these sliders, each slider representing KP, KI and KD. So their values, they don't resize well, unfortunately. That's tkinter for you. So KP, KI and KD, these are directly being sent over to the drone with a scaling factor, as I mentioned earlier. So what you can do now is, I'll just press Ctrl C and just close this. Okay. We'll just look into the functionality of the launch files as well. So here you have both launch files for the drone and the differential mode. So let me just edit the drone launch file. I'll open it first and I'll show you. here. So Sublime was here, it opened here. Launch files are XML files, so I'll just do XML over here. So all this launch file does is just select whether to launch everything or not. So you can just pass parameters to it. So this is pitch, roll, yaw, and throttle. So as you see, throttle has been made false. So if you run it from the rosrun or the Python script, that script directly, all of them will show up. But if you use the launch file, you can choose to disable these as you wish. So while tuning your PID, it is always good practice to tune one thing at once. So as it is, yaw has been made false because we'll not be tuning yaw over here. So let me make pitch and roll as false as well. So just one GUI pops up instead of all four of them. So that is a bit overwhelming, isn't it? So now only the throttle thing will pop up. And now let's run our launch file. So ROS launch PID tune and drone.launch. So after I run the launch file, you notice now only the throttle GUI popped up. So I'll just move this to workspace 3 as well, right where our plot juggler is. So drone over here, plot juggler over here. So now I can, if you want, you can also do this with the Vicon readings as well. So I'll just reset this. And now you'll see the alt error, which is shown in yellow, changing as I increase the KP over here. So KP is going there with a scaling factor. And now KP has overshot. Oh no, has it exceeded the Vicon boundary? Well, we'll check. We'll also publish Vicon, move to another workspace. Let's probably move this in workspace 3 as well. So where is our Vicon? Oh, I can just have this here. Move. Okay, and then so with just the KP, our drone is oscillating about 0 basically. If I increase it too much, it will just overshoot and then escape the camera frame and everything like that. Okay, so now KP has increased. Seems to be a good enough value. It's oscillating about that. I'll just increase the KD a bit. So if you've gone through the tutorials already, you must know the functions of all of these things. So KP just causes oscillations. KD is just there to put brakes on things. So when it gets close to the set point, the rate at which it oscillates, like it just settles down, puts brakes on things. Okay. So then I decrease the KP. I'll increase the KD as well. Your zero line also shifts. So what you could also do is publish something, a topic of a zero line which is constantly 0. So that will help you, ascertain where your 0 is. So I'll increase, it's still oscillating, so I'll increase KD even more. The error is not much, but yeah. So yeah, more KD, maybe just a little bit of KI, just to get rid of the constant error. And now if in my gazebo okay, that's too much KI, I guess. Still a steady state error at 0.5. So increasing KI is a very risky thing because it increases the instability of the system as well. So yeah, see, I reduced KI, it shot right back down. So So this is hovering at pretty much very close to 0, much like well within our threshold. So now, in order to check the response, what we'll do is just press Ctrl Shift R, have this reset, and just check the response. Oh yeah, there's still some overshoot, so we can increase the KD even more. Go here, reset, and increase, and more KD. So if in case you run into this situation, it will be very helpful in order to change the ratios, the fractions of which you're multiplying this value back where you have subscribed it. So in my case, I think it is 0.03. So essentially a KD of 2500 will approximate to a KD of value of 2555 here will approximately be KD of 75 if my multiplier is 0.03, if my math is correct. So yeah, you can change around the multipliers and then see the responses and everything. So response over here again is okay, good enough, like within 3 seconds of simulation time. So keep in mind over here, this these values which are being displayed on the x-axis here are time values, and you might notice they are coming slowly, rather slowly than the real time. This is because all of the clock when you're using the simulator, the clock for the ROS packages, everything which runs, the publishers, the subscribers, the forces which go through to the drone, the rate at which the camera captures the video feed, everything, it is based on a clock, okay? But when you run the simulator, by default and by necessity also, in order to keep all of those force values constant, the clock which ROS uses, the topic / clock as well. So yeah, I'll just show that to you once. So ROS topic list. So if you can see here, the second topic which is being published is clock. So everything is synced via this topic, okay? And for better or for worse, when you run the simulator, the clock topic is actually published by the simulator, okay? So you might have noticed in real time 23 minutes have passed, but in simulator time only 6 minutes have passed. This is because the simulator is under a pretty high load, so even my system over here can't cope with the load. This is perfectly alright because all of the constants which are going to the simulator, all of the forces, the velocities and everything are in the sim time clock. So the real time factor over here in the bottom, as you can see, is 0.30. That approximately means it is like literally a third, essentially, third of the real time. So 3 seconds in real time will correspond to 1 second in simulation time. So your real time factor may vary. There is no need to be worried about it because everything is published in the simulation time clock. So as you can see, our response was pretty good. Just within 2 to 3 seconds of simulation time, it reached its throttle value. So similarly, now by changing the launch file, making the things from false to true, I'll consider throttle as tuned. That's great. So you just make note of these KP values, just multiply them with whatever threshold you're getting, and they reflect them what you're using, and then you can reflect them directly in the list. So throttle is tuned, great. So you can do the same things with roll and pitch now. So in the interest of time, let's not do that. So, but if you are going to do that, you just now set this to true. In the meanwhile, just reflect the values of the throttle in your KPK and KD of your position hold script. And yeah, that's it. You can just make this true, launch the whole thing again, and tune your roll and pitch. Simple enough, right? So I hope you have all the success in the world in completing this task. We really hope you do this, and after this is just waypoint navigation. So that is just having multiple set points. So after you reach one, you just keep checking if you have reached one set point, and then you just switch over to the other if you have reached that set point. So we really hope you complete these tasks, because stage 2 is pretty very extremely exciting. Like, trust me, it is really exciting this time around. So lots of stuff to do in stage 2 as well, lots of new concepts to learn as well. So we really hope that this package over here helps you get your hands dirty with the drone and how it functions well before you get the actual drone. So yeah, just put in your best. All the best. Good luck. Bye.